Good morning, everybody. This is G. Om Kedareshwar Kiran from Electrical and Electronics Engineering. Today's my topic is about graph structures and algorithm. Graph data structure is a collection of nodes connected by edges. It's used to represent relationship between different entities. Graph algorithm are methods used to manipulate and analyze graph, solving various problems like finding the shortest path or detecting cycles. Graph data structure are very powerful tool for representing and analyzing complex relationships between objects and entities. They are particularly useful in fields such as social network analysis, recommendation systems, and computer networks. In the field of support data science, graph data structure can be used to analyze and understand the dynamics of a team performance and player instructions of the field. Components of a graph. Vertices. Vertices are the fundamental units in the graph. Sometimes vertices are also known as vertex or nodes. Every node vertex can be labeled or enabled. Edge. Edge are drawn or used to connect the nodes of the graph. It can be ordered pair of nodes in direct graph. Edges can connect any two nodes in any possible way. There are no rules. Sometimes edges are also known as arcs. Every edge can be labeled and enabled. Basic operations on graph. Below are the basic operations on the graph. Intersection the nodes edges in the graph. Insert a node into the graph. Deletion of nodes edges in the graph. Delete a node from the graph. Searching on graphs. Search any entity in the graph. Transversal of graph. Transversing all the nodes in the graph. Insert a node of graph. Search and node graph. Applications of graph. Following are the real-life applications. Graph data structures can be used to represent the intersections between players on a team, such as passes, shots, and tackles. Analyzing the intersections can provide insight into a team dynamics of areas to improvement. Commonly used to represent social networks such as networks of friends and social media. Graphs can be used to represent the topology of computer networks such as the connections between routers and switches. Graphs are used to represent the connections between different places in a transportation network such as roads and airports. Graphs are used in neural networks. In vertices represents neurons and edges represent the sign space between them. Neural networks are used to understand how your brain works and how connections change when we learn. The human brain has about 10 root 11 neurons and close to 10 root 15 synapses. Here are the types of graphs. There are total 11 types of graphs. The first one is null graph. A null graph is known as the null graph if there is no edge in the graph. When there is no edge in the graph, it is known as null graph. We can see the diagram below null graph. There are only vertices in the null graph. There are no edges in the null graph. The second one is trivial graph. Trivial graph having only a single vertex. It is also known as smallest graph and possible graph. Below we can see the trivial graph. It is having only vertices, only one vertex. Third one is undirected graph. A graph in which edges do not have any direction, that is, the nodes are unordered pairs in the definition of every edge. The undirected graph, you can see the diagram, there is no arrows representing the direction. Fourth one is directed graph. A directed graph which edge has direction, that is, the node are ordered pairs in the definition of every edge. Directed graph, we can see the diagram of the directed graph. It is having arrows representing the directions. These are the difference between undirected and directed graph. Connected graph, a graph in which form of node we can visit and another node in the graph is known as connected graph. Below we can see the diagram of connected graph. Disconnected graph, the graph in which at least one node is not reachable from a node is known as disconnected graph. Below we can see the diagram of disconnected graph. There is no connection of edge within the vertices. These are the difference between a connected graph and disconnected graph. Regular graph, the regular graph in which the degree of vertex of every vertex is equal to k is called k-regular graph. Below we can see the two regular graph diagram. Complete graph, the graph in which each node there is an edge to each other node is called a complete graph. In the complete graph, each vertices and connected to each other vertices with equal nodes, it is known as complete graph. These are the difference between two regular and complete graph. Cycle graph, the graph in which the graph is a cycle in itself. The degree of each vertex is 2. The cycle graph, we can see the diagram of cycle graph. Each vertex is having two edges with 2 degree. Second one is cycle graph. A graph containing at least one cycle is known as cycle graph. Below we can see the diagram of a cycle graph. These are the difference between cycle graph and cyclic graph. Directed acyclic graph. A directed graph does not contain an cycle. Directed cycle graph, there is a diagram below. Bipartite graph, a graph in which vertex can be divided into two sets such that vertex in each set does not contain any edge between them. Below we can see the diagram of bipartite graph. In the graph theory, the bipartite graph is very important thing. Now coming to the representation of graphs. There are two ways of store in a graph: adjacency matrix, adjacency list. Coming to the adjacent matrix representation of a graph, in this method the graph is stored in the form of 2D matrix where rows and columns denoted vertices. Each entry in the matrix represents the weight of the edge between those edges. Below we can see the diagram of adjacency matrix of a graph. There are the vertices 0, 1, 2, 3, and 0 having the vertex with 2 edges, 1 with 2 edges, and 2 with 3 edges, and the adjacency matrix of graph is represented there. Now coming to the adjacency list representation of graph. This graph is represented as a collection of linked lists. There is an array of pointer which that edges connected to the vertex. Adjacency list of graph. Below we can see the diagram here on adjacency list of a graph. Now coming to advantages of graph. There are many advantages in a graph. The graph are a visualized data structure that can be used to represent a wide range of relationship and data structure. They can be used to model and solve a wide range of problems including pathfinding, data clustering, network analysis and machine learning. Graph algorithms are often very difficult and they are used to solve complex problems quickly and efficiently. Graph can be used to represent complex data structures in a simple and initiative way, making them easier to understand and analyze it. Now coming to the disadvantages of a graph. Graph can be complex and difficult to understand, especially for people who are not familiar with the graph theory and related algorithms. Creating a multiplying graph can be used computationally expensive, especially for very large and complex graphs. Graph algorithm can be difficult to design and implement correctly and can be prone to bulge and error. Graph can be difficult to visualize and analyze, especially for very large or complex graphs, which can make it challenging to extract meaningful insights from a data. These are the advantages in graph and also disadvantages according to the data structures of a graph. Report. These are the graph structures and algorithms with the given graph and algorithm data structure are combined. Thank you.